Hi, we are going to present our COA project. Here is our list of content. Okay, here is our group members. I'm Zheng Yu, the group leader. Yee Hao, member. Chang Wei Lam, member, and also Angie, member.
So the problem background is, in the fields of computing, benchmarking is a crucial process used to evaluate the performance of computer systems by running a series of standardized tests. These benchmarks help in assessing the capabilities of different hardware components, particularly the CPU, Central Processing Unit, which is often regarded as the brains of computer. CPU benchmarking involves the series of tests designed to measure various performance metrics such as processing speed, efficiency, and abilities to handle different workload. The result from these benchmarks provide a comparative analysis from different CPU, which is essential for making informed decisions about hardware upgrade, system optimization, and the understandings of the overall capabilities of computing system. So for the aims of the project is to explore and analyze CPU performance using various benchmarking tools that is free that can help us to understand the nuances of CPU benchmarking and the factor that influence CPU performance. We also can compare the performance of different CPU under various workload that providing insights into their strengths and weakness. The objective of this project is to understand the principles of CPU benchmarking. We gain a foundational understanding of what CPU benchmarking entails and the different types of benchmarks used in performance analysis. The second one is to compare CPU performance. We perform benchmarks on different CPUs to compare their performance under identical condition. The third one is to analyze impacts of workload. We examine how different workload affect CPU performance and resource utilization. And the last one is utilize benchmarking tools. We learn to use various free benchmarking tools effectively and interpret the result they generate. So the next one is computer specification. The project involves benchmarkings of 4 different computers on notebook all running on the Windows OS. The specifications of this computer will include details such as CPU model, clock speed, cache size, memory, and motherboard information. This specification will be collected using tools like CPU-Z and validated with GeekBench in system information.
Now I'm going to talk about the benchmarking tools features. For the first one is CPU-Z. CPU-Z is a freeware that provides detailed information about the CPU, including clock speed, cache size, and other critical specifications. It also includes simple benchmarking features. CPU-Z can report real-time CPU frequency, core voltage, and memory details, such as type, size, and timing. It features a basic CPU benchmark that measures single-thread and multi-thread performance. Result can be compared against a database of other CPU results. CPU-Z also provides information about the motherboard, including the chipset and BIOS version, as well as details on the graphic card and SPD, data from the memory modules. The second one is GeekBench. GeekBench is a cross-platform benchmarking tool that measures the CPU, single-core, and multi-core performance using various real-world tasks and applications. GeekBench provides detailed system information, including the OS, processor model, and memory details. It runs a series of tests that simulate real-world scenarios, such as image processing, encryption, and machine learning tasks. To evaluate CPU performance, it also provides a comprehensive score for both single-core and multi-core performance. GeekBench support multiple platforms including Windows, Mac OS, Linux, Android, and iOS, and enabling comparison across different devices and operating systems. The third one is the most common one, Windows Task Manager. Windows Task Manager is a built-in tool in Windows OS used for monitoring system processes and performance under different load conditions. High, medium, low CPU loads. It provides details information about CPU, memory, disk, network, and GPU usage. It also shows details of running application and background processes. User can observe how different processes and applications impact CPU and memory usage in real time. It provides graphical representation of CPU loads, memory usage, disk I/O, and network activity. Task Manager can be used to simulate different workload conditions by running various applications and monitoring the impact on system performance. For example, it can help assess how rendering a video, gaming, or performing office tasks affect CPU utilization. The last benchmarking tool is Crystal Disk Mark. It is a benchmarking tool used to perform this benchmarking, including stress tests for read and write operation on external disk, HDD or SSD using different modes like sequential and random. It measures sequential and random read-write speed with detailed result. It supports multiple test size and quick disk to simulate different usage scenarios. Crystal Disk Mark tests sequential read-write and random read-write, which are critical for understanding the performance of storage device under various workload. It provides customizable test settings, including the number of test pass and test size, allowing users to fine-tune the benchmarking process. It also supports NVMe, SSD, HDD, and USB drive. So I'm going to do the demo video on how benchmarking on CPU by using CPU-Z. So you just simply search and open the CPU-Z on your laptop. Then you can navigate through the tab to see the information. The CPU, you can know the details about the processor, including names and code name, package, technology, and core speed. Okay. At the bottom one, you can see the information about different level of CPU cache. And the mainboard tab, you can know the information about motherboard, including manufacturer, model, and BIOS. So at memory tab, you can know the details about the system memory, including type, size, and timing. And we got a few more tabs like SPD to know the information about the memory module installed in the system, graphic to know the details about the graphic card and GPU, And the last tab is bench, allow you to run benchmark and compare your system performance with other system.
I'm going to demo how benchmarking of CPU by using GeekBench. So first we open the GeekBench and then we press once run CPU benchmark. So here are the results. So the single core score measures the performance of running the task on a single CPU core, while the multi-core score measures the performance of running the task on all the CPU core. So for the GeekBench, we can see the system information like the model and the type of the operating system, and also the CPU information, such as the maximum frequency, the package, the code name, and also memory information like the size, the transfer rate, and these are the more detailed information about the single core performance and also the multi-core performance. So for single core performance, we can see the rate for the file compression, navigation, and also the text processing. And for the multi-core performance, we can also see like the rate of the file compression, like the access compression, and like the rate of doing different tasks. So now I'm going to demo how benchmarking our CPU using Crystal Disk Map. So first we open the Crystal Disk Map and then we press O. Here are the results. The Crystal Disk Map is used to test the speed of any storage device or memory card. The program measures the read and write speed for an accurate measure of performance. This means that sequentially read and write data will access on 1 MB with a total of 8 tasks on 1 thread of the processor. This means that sequentially read and write data will access on 1 MB with 1 task on 1 thread of the processor. And this means that rendering read and write flow can be data with 8 tasks in the queue on 16 threads of the CPU. And this means that rendering read and write flow can be data with 1 task on 1 processor thread. So now we open the task manager, and so we can directly see the list of the process and the application currently running on my computer system on this process tab. So performance tab, it will show the real-time data on the usage of system resources such as CPU, memory, and disk on the performance tab. So this will show the CPU utilization rate. So CPU utilization is the amount of work a CPU does to perform the task given to it. So here are the detailed information, and this indicate the memory usage. So memory in use means that indicate the current RAM usage, and this commitment part is indicate how much memory I can totally commit on the system. And the patch tool here consists of virtual memory that can be patched in and out of the system, and non-patch tool is data in RAM that can be moved into the patch file. And this show the temporary data, and this is the amount of memory that can be immediately useful by process driver and the operating system. Now I want to know how to release the memory consumption. So this is my current memory consumption. So first thing is we need to remove all the running app. So we may go to here and then right click and click logout, exit or quit. And then we have to close the running app. So now we close the running invisible program. I will close the program that uses the more memory. Okay, so now we remove the startup application. And then now we can see that the memory is decreased from like around 94% to 56%. I'm going to use Task Manager to simulate impact of different workload on the memory consumption. So now is the low CPU load. I only open the Microsoft Kitchen app for video recording, and I have also closed some invisible program. So as you can see here, the memory consumption now is 48%. Now I'm going to simulate the impact of misload on the memory usage by running a code. As I use the Google Meeting to record the video, so now the memory usage is more than 50%, and now it's 52%. So running code. So the output didn't show here because the code stack here is still running. So as we can see just now, the memory usage is increased until 57% from 52%. Now I'm going to simulate the impact of the high workload on the memory usage by exporting a 10-minute video and running a code. So now I export the video. So as the code is running and the video is exporting, as you can see the memory usage is more than 80%, and now it's 81%.
Now I'm showing the benchmarking result. For the CPU specification, we've tested the number of core threads, thermal design power, clock frequency, and CPU performance of 4 computers. For sesh specification, we also test the size of L1 data and L1 instruction, and also L2 and L3 sesh. For motherboard specification, we also compare the bus specification. For the memory specification, we also compare the memory size, transfer rate, and also the maximum bandwidth. For memory performance, we are testing when you're processing a large file, a small file, and we have the calculate the difference between the mid and low load and also the mid and high load. For the part 2 CPU benchmark, we have tested about the different CPU millisecond in different number of the loop. Now we are going to the comparison part 1. In terms of the model name, the computer C is the 13th generation i5HX series, which has the most powerful advanced generation and superior mobile capabilities. For the computer A and B, which is 11th gen i5, the B will outperform A due to the higher SKU. For the computer D, Ryzen 7 5700U will be the energy efficient but weaker in performance. As you can see, the single core performance, the stronger is the computer B, which is 2082. The weakest are computer D, 656. For the multiple core performance, the stronger is computer C, but the weakest are the computer D. For the motherboard specification, the computer C is stronger with PCIe 5.0, have higher bandwidth, faster transfer rate, and able for the future upgrade support. But for the D, is the weakest PCIe 3.0, have a lower performance. Okay, for the memory performance tests, the computer D is strongest in the large file because of the DDR5 memory, and for the small file operation, the B are the strongest due to the 24 GB of the memory. And for the balance performance, computer A, for the weakest are the computer D due to 8 GB memory. For the search memory, the computer C have the largest total L1 search and also the 24 map share level 3 search. For the computer B are uniform, the computer A are the smallest, and the computer D have a lower L2 and L3 search sizes. Now we're coming to the part 2. For the CPU millisecond difference analysis, we can note that the progressive increase in CPU time with the loop count will be nearly doubles from the 50 loop to the 100 loop, and it have an exponential growth in compatibility and also the processing demand. Okay, in the discussion, the computer A have a balanced overall performance, but a lower CPU and memory performance score, and it is suitable for less demanding tasks and for general use. For the computer B, it excel in single core performance, and it have a larger memory and best in small file rate and write speed, and it is suitable for both single thread and multiple thread application. For the computer C, they have a best overall performance and it will optimal for the parallel tasks like video rendering, and it is suitable for demanding application and future upgrades. For the computer D, have the weakest overall performance, but its focus is energy efficiency. It is suitable for energy efficient and lightweight device. So the overall performance ranking from the ascending order is computer D, computer A, computer B, and computer C. Lastly, for discussion part 2, we can note that the CPU time increase when the number of loops increases. It is due to the exponential growth with the higher loop count. And we have learned the importance of efficient algorithm and minimizing unnecessary loops. And we will also have a leveraged understanding of CPU behavior under the different workload of high performance software development.
Continue with the part 2 ASM code. So firstly, we define the coefficient A, B, and C, and D with our team member's birthday date, and we declare for data. And here's the message that we will out display to let the user to enter its output. And we will calculate the first capture execution times and the second caption execution times, and we will calculate the different execution time also. So if the user are entered invalid input, so we will ask the user to enter it again. And here's the code that for our process. So we start the code, we display a message, and we will go to the loop stress. Here's the value that entered by the user. It will come to here and done for the looping, and it will loop for the numbers that the user enter, and we will get the capture time. So when it's finished the looping, we will get a second capture time, and we calculate the differences. So let me show you how it's working. So firstly, I enter 10 loop, and here's the first capture time, so and the second capture time. So we get the differences for the capture times is around 1,000 and 164. So we can get the value of sum also. And if we continue with the 100 looping, so we will get the first capture time is before the loop start, and the second capture time is after the loop end. So we'll get the time, and we calculate the difference is around 10K, and the value of sum is around 29,000. So we can get the conclusion is when the looping is increased, the numbers of looping is increased, so the differences between the execution times also increase. So I think that's all from me. Thank you.
In conclusion, the four computers demonstrate varying strength across different performance metrics. Computer C equipped with a 13th generation Intel i5HX series processor, PCIe 5.0 and DDR5 memory excel in high performance tasks and future proofing. Computer B offers a balanced mix of strong single-core and multi-core performance. Computer A provides reliable performance for less demanding tasks, while Computer D, with its Ryzen 7 Mobile 5700U, focuses on energy efficiency. Suitable for mobile and less intensive use. The difference in CPU generation, PCIe version, cache configuration, and memory types highlight the importance of aligning hardware specification with specific use cases to optimize performance and efficiency. In part 2, the analysis of CPU m-second difference as the number of loops increase demonstrate a clear exponential growth in CPU processing time. This significant rise from 5,541 millisecond for 50 loops and 111,064 millisecond for 1,000 loops emphasize the substantial impact of loop count on CPU performance. The result highlight the necessity for optimizing loop structure in assembly language to enhance efficiency. Understanding this dynamic is crucial for creating high-performance software capable of handling complex tasks without imposing excessive processing demands on the CPU. Through this project, I gained a profound understanding of CPU benchmarking and its critical role in evaluating computer performance. By exploring and utilizing various benchmarking tools, I was able to compare the performance of different CPU comprehensively. Analyzing the result highlighted the impact of CPU architecture, cache configuration, memory types, and PCIe specification on overall performance. This hand-on experience reinforced the theoretical concept of COA, emphasizing the importance of choosing the right hardware component. Additionally, work with my peers enhanced my teamwork and problem-solving skill, providing a holistic learning experience.
Reflecting on my recent project, I gained a comprehensive understanding of analyzing and benchmarking key computer components, such as the CPU, flash, memory, and motherboard, selecting appropriate specification to compare performance. I also developed skill in choosing better computers based on these three comparisons. Additionally, the COA project enhanced my teamwork skills, as collaboration was essential in solving complex problems. I learned to find and utilize various resources and references to support our analysis. This experience not only improved my technical knowledge, but also boosted my confidence in working with others to achieve common goals, making me proficient in evaluating computer system and collaborating effectively.
The project made me understand what different tools used for benchmarkings are and what methods are used in each case. The knowledge about CPUs and hardware performance sequencing was successfully in helping me to realize the importance of various benchmarks and how they are done. Also, during the time, I was able to see that many things affect the performances of CPU, such as its speeds, which may change depending on items connected to it. When analyzing the systems separately but side by side, it will enable me to have a clearer understanding when interpreting the result obtained from tests so carried out. Additionally, I developed interpersonal skills through collaboration with my teammates on group work in our technical classes, which require teamwork for successful completion.
Participating in a group project on CPU and hardware performance benchmark gave us a clear understanding of how benchmarking works and why it's important. We learned to use tools like CPU-Z, GeekBench, and Windows Task Manager to measure and compare the performance of different CPUs. This taught us the importance of being precise and careful, as getting accurate results require proper setup and consistent testing. Analyzing the data helped us understand complex performance number and find key insight, improving our analytical skills. Working through the challenges of getting accurate results and coordinating as a team saw us the value of collaboration and flexibility. Overall, the project not only taught us a lot about CPU benchmarking, but also prepared us for future tasks that need careful data analysis and teamwork.